Hello, this is Brian Slocum back with another Fusion tutorial. This time we are looking at a mechanism project that I used as an example for a nesting tutorial. We're looking at that same project, and this time we are looking at joints. So here's my mechanism project. All I've done to this is I've changed the physical appearance of things so that we can see all of these elements as different colors. And so to highlight this, ultimately I would love this thing to be able to function inside a virtual environment, so I can check to be sure that it works the way I'm expecting it to before I spend money physically prototyping this. So probably should have done this before I did the nesting example, but here we are now. So what you'll see is ultimately this thing should revolve and this arm should move in and out and this thing should all slide together. But if I grab any of these pieces, they actually move around as individual components and they're not in any way tied together. And that is the function of joints inside Fusion. It's to apply some physics to them, degrees of freedom. We're going to really try to decrease the degrees of freedom that each of these parts can move in. So right now these have a lot of degrees of freedom, right? I can move it in the X direction, I can move it in the Y direction, I can actually move it, if I click on it, I can move it in the Z direction, right? So I have lots of options here for how I move these things around. I can also rotate this. Again, if I do that same move component and I click on this guy here, we can revolve it this way, we can revolve it this way. So look at all of these degrees of freedom I have about this one part. The idea behind joints is it is going to limit those degrees of freedom and create relationships between objects. And we want to do this in order to constrain these objects so they only function in the way that we want them to. So to start out, the first thing we need to do is we have to ground something, because right now all of these parts, I can move every single one of them. I can grab this guy and move this around as well. All of these parts can be moved. And if I create relationships between them and I don't lock something down, then you won't be able to see the true motion of how these things are designed to work together. So in this case, you have to make a choice about what gets fixed, and for me it's the base plate, because that in the real world this is either going to sit on the ground or stand up on a stand, and that's going to get locked. So I'm going to hover over base plate, I'm going to right click, and I'm going to click ground to parent. This will pop up. So you notice that I moved this thing around. It's going to say hey, this is going to override the move, and the base plate may revert to its initial insert or in-place creation, and that's okay. Yep. So I'm going to click ground to parent, and that thing will move back to where it was. There we go. It's locked there, and you'll see now if I click and drag, I can't move this. If I click and drag, I can move that. Click and drag, I can move that. Click and drag, I can move that. Click and drag, I can move this. So I can move all those other things, but I cannot move the base plate. All right. Now we're going to start to create joints. There's a lot of types of joints. I will do another video that explains what each of them is in detail. I'm not going to take time in this video to do that. We're going to use at least 3 different types here. And I'm going to kind of start from maybe big to small or simple to more complicated. And so the simplest thing is I want this rotary plate to be fixed so that it only rotates about this axis, right? This center pivot point. I don't want it to be able to slide left or right. I don't want it to be able to slide up or down. I only want it to be able to rotate about that axis. So I'm really limiting the degrees of freedom about rotational plane, about movement along axes. I'm getting rid of all of those except for a single rotational degree of freedom. So for joints, the icon is right here in the Assemble menu. If your interface looks slightly different, you can find it under Assemble as Joint or by hitting J. Those quick, I don't use those, the keyboard shortcuts nearly as much as I should. All right, when I do that, it pops up our little menu here. You'll notice that there's 2 tabs. I'm going to click over to the Motion tab, and it's already pre-selected as revolute. It grabs whatever you used last time. If you click on that, you'll see all of these different options for motion. Each one of these is going to constrain your parts or your components in different degrees of freedom. Revolute probably has the most constraint outside of rigid, which constrains all orientations. So I'm going to choose revolute, and position here, I'm going to keep it a simple interaction between the two components. So I didn't say this, but the important part here is you'll note these are no longer bodies. I've made these all components. The only way joints work is with components. You cannot create joints between bodies in Fusion. So these have already been made into individual components, and so now it's asking me, all right, select your components that you want to create the relationship for, and what do you want it to snap to? So essentially, I need to find a common point about these two components, this guy and this guy, where they are going to revolve around one another. This is going to be specific to both point and plane, and that distinction is really critical. So this one's easy. I want to zoom in here, and I just want this the top plane. I don't want the bottom one. I don't want the one down there. I want the one at the top here. And here's a little trick inside Fusion. If you hover over the face that you want, on a PC, if you hold down Control, on a Mac, if you hold down Command, it's going to lock that face. And now you'll note I can't grab that point down below. It's not going to swap between them. And that allows me to select that point. The minute I hit the point that I'm selected to, that component will now turn transparent. And that's letting you know, like, you can no longer select that. When you've already selected it, now you need to choose a relationship with another component to create that joint. And for me, it's this one here. But here, I don't want this top face, because if I chose that, it's going to try to put this plane and this plane together, which means it's going to flip this thing 180 degrees. And I want this side pointed up. So I'm going to rotate to the bottom plane so I can see it a little bit better. I'll zoom in. Again, I'm going to hold down Command once I have this face highlighted, and I'm going to choose that center point. You'll notice when I do that, it's going to move these two things together. And if I click OK, it's going to create that joint. All right, so aside from that move, it looks like not a whole lot happened. But if I use my cursor, if I click and drag now, you'll note I can no longer move it left or right, up or down, but it is now rotating about that axis. So it's created that joint, that relationship between those two center points. All right, so now we need to do another joint to further constrain these components together. If I were doing this in another format, I would probably choose to create a joint between this hole and this hole here, but I just want to show you how an ungrounded component will not constrain the degrees of freedom that you want. You actually can't see how the joint works. So I'm going to use that same revolute joint between this center point here and this center point here. And again, the planes are really important, and I'll show you the flip command here in a second. So I'm going to click joint. Again, I could click J, click motion just to make sure revolute, yep, that's correct. What are my points? So I'm going to go over here, find my face, hold down Command, click that center point, and I'm going to come over here and rotate around because I want this bottom face, hold down Command, click that center point. It's going to move those two things together. And I'm going to click OK. Oh, wait, before I click that, I just want to show you flip. So you'll notice I chose this top face of this component, and I chose the bottom face of the green component. If it gives you the wrong relationship between those, there is this little flip button here. If I click flip, you'll note that it's going to keep those same planes aligned, but it's going to invert the geometry of one of those objects. So in this case, it took that blue part, and it kept what you're seeing is it's flipping that 180 degrees. These two things now occupy the same space. I'm breaking the laws of physics. that can't be possible. So that is the incorrect orientation. So make sure you can play with the orientation of those joints together. Also here, and I'm not doing this, but you can actually change, you can have an offset in any axis that you want in the X, Y, or Z, and I can change the alignment to have a certain fixed angle inside of these joints. But this is good the way it is, so I'm going to click OK. You notice when I do this, my timeline, I'm adding these joints, they're just like any other feature. I can go in and edit these joints later. I can also edit motion limits once I have them, which is going to constrain like how far these things can move in different orientations. But in this case, I don't need to do that. All right, so I've created my second joint. So my first one's here, my second one's here. This one is a revolute joint, so this thing should be able to rotate around this axis. But if I click on this to show you that it's a revolute joint, you notice that it's not revolving, it's just moving that whole element. This is what happens if you don't ground something, or if something isn't joined to something that is ground. It has too many degrees of freedom and you're not going to be able to see that motion. So here, oh, I can't move it, it will rotate. Here I can move that whole object. So great, that's a clue to me that I need to create another joint between this object and some other part. Typically work from your grounded elements out. So here, this hole and this hole need to have a relationship, and that's just another revolute joint. So I'm going to click joint, motion, just double check that it's revolute. Position here, I'm going to come over here to my hole, top surface, hold down command, find that center point, super terrific. That turns transparent. I'm going to revolve and I want the bottom face of this guy. Select that, hold down command, choose that center point, and we'll click. It's showing us, it's previewing what that's going to look like. It's moved my disk up to this object. Don't worry about that. That's just previewing that single joint, and then it's going to go back and compute the other joints. So again, flip here. I can flip these things. Nope, that doesn't look right. Much better. Okay, so I click OK. All right, so now joint here, joint here, joint here. If I click and drag, ooh, whoa, this thing starts to flip around. You'll see, oh, that blue part now can rotate around the axis. If I grab that, you'll see all these things are orienting in all these different ways. All right, so for this mechanism to fully function, I need this hole to work inside this slot. For that to happen, I need a pin. I want a pin slot connection. Ooh, here's my pin. But if I just do a pin slot connection between here and here, this doesn't have a relationship to the blue and green parts. So I'm going to first create a relationship between my pin and my center hole, and then I'm going to create the relationship between my pin and the slot. So we're going to do a different joint type here, and I am going to use a cylindrical joint. So if I click on joint, I'm going to click motion, and I'm going to move from revolute to cylindrical. Cylindrical is going to have that same rotational axis like the revolute joint, but it isn't going to constrain in plane. So that pin will be able to move up and down in the Z orientation, and you'll see this here in just a second after I create that joint. My joints are going to be pretty much the same. So I am going to select different components. So here I'm going to revolve around this guy. I'm going to choose the bottom face of this, hold down command, and find the center point. And I'm going to revolve back around, and I'm going to create the top face of this guy, hold down command, and select that center point. It's going to move those around. This thing can revolve. Again, flip command is there, but it looks like it's the right orientation, so I'm good to go. I click OK. And this will, you can see now, I can't move this thing left and right, but I can move this thing up and down, okay? So this is important for this particular interaction because the pin slot, when you select something for a pin slot, that planes need to be aligned. And this pin is longer than the thickness of this thickness plus this thickness plus this thickness. The pin is longer than that. So if I constrained the pin so that the bottom face of the pin aligns with the top face of this, the bottom of the pin is going to stick through the bottom of my object. And then if I try to do a pin slot joint, I'm going to get an error that these two things aren't aligned. But by making it cylindrical and allowing this thing to move up and down, that is going to automatically create that relationship between the slot and the bottom of the pin. So I'm just thinking a little bit ahead here about how joints work to try to create appropriate relationships so we don't have an issue with this moving forward. All right, so last joint we need to do is the pin slot joint. So I'm going to click Joint, Motion, Pin Slot. This one's so cool. Go back to Position. What am I going to select? I'm going to select the center point of my pin. There you are. And I want to select the center point of my slot. It doesn't matter which one it is. So again, hold down on the face, hit Command so I don't select the wrong thing. Select that point. Oh, so here's a perfect example. Look, it flipped these guys upside down. That's not the relationship I want. I'm at my pin above. So I'm going to flip that over and click OK. And you'll see when I did that, the pin now sits a little bit high. So like, all right, in the real world, do I want that pin to sit up there? Not really, but this allows me to like have a longer pin and still create that relationship, because essentially that pin is going to have degree of freedom in the z-axis anyway. So that's showing me that relationship. The lovely thing about this now, everybody watch, is I've constrained this, I fully constrained this object. So if I click and hold, now this mechanism only works in the way that I want it to, right? So I can rotate this wheel and it's only going to slide in that slot, and we have now demonstrated that this has the right motion. I can check motion limits here by making sure when that's fully extended is, do I have intersection with my slot? So this allows me to investigate. Nope, I still have room there. Yay, all right, so I've made my slot long enough. And you can do the same thing, obviously, on the other side. All right, I will do another video to show you how we can automate this by doing a motion study, but we're gonna end this video here. Hopefully you learned something interesting and how the power of joints can be leveraged to make your mechanism fully function. Thanks for tuning in. I will see you later.